Hey everyone, and welcome to this explainer. Today, I actually want you to put on your metaphorical trench coat and grab a magnifying glass, because we're going to become energy detectives. We are diving deep into your facility's hidden inefficiencies to uncover a silent crime that's likely happening right under your nose.
I want you to picture your building at, say, 2 in the morning. The doors are locked, the parking lot is completely empty, and the lights are supposedly all off. But is it really asleep? Is your building secretly wasting energy tonight when literally no one is around to watch it? Well, the unsettling truth is that for a massive number of facilities, the answer is a resounding yes. They are draining power and bleeding money in the dark.
Out-of-hours energy use is absolutely the biggest, most pervasive hidden cost in modern facility management. And we aren't just talking about a forgotten desk lamp here. An enormous amount of electricity is drained silently during nights, weekends, and holidays. A prime suspect? Your HVAC systems. In the United States alone, HVACs accounts for a staggering 75% of the total electricity produced for buildings. So when these massive systems fail to power down during out-of-hours periods, the financial and environmental waste is just immense.
All right, so here's our game plan for today. We'll start by identifying the hidden energy thief, then move into reading your energy profile, spotting the waste, crunching the numbers, and we'll wrap it all up with a 5-point action checklist and some next steps.
Okay, stepping right into part 1, the hidden energy thief.
The whole foundation of our investigation starts with a really critical concept, and that is called baseload. Baseload is the minimum amount of energy a building uses during those out-of-hours periods when it's supposedly totally empty. Now, obviously, some baseload is necessary, right? You need it for servers, security systems, emergency lighting, but a high or wildly fluctuating baseload, that is exactly where our hidden thief operates. This constant, silent drain is what we really need to interrogate.
Now, to catch this thief, we're going to need better data. And this perfectly illustrates a really common mistake that a lot of facility managers make, relying solely on EUI, or energy usage intensity. EUI is just a static annual metric. It basically just normalizes yearly consumption by square footage. It's kind of like looking at a single photograph of a moving car and trying to figure out how fast it's going. It just oversimplifies performance. To really see what's happening, we need load-shaped profiles. These give us temporal, hourly, or even half-hourly data. They show us the actual daily curves, which lets us spot exactly when and where that off-hour waste is happening.
Moving right along to part 2, reading your energy profile. A power heat map like this one beautifully exposes building operations over a full year. You'll notice the horizontal axis is the hour of the day, and the vertical axis spans the entire calendar year. The redder the color, the higher the power draw. Just look at that crisp daily schedule right in the middle. From 7 a.m. to 10 p.m., the building is awake, it's active, and it's drawing heavy power. Then look over to the left, and you can see distinct horizontal banding. Those are your lighter weekend schedules. You can even see the intense summer cooling season bulging out in the middle of the year, running slightly after hours. When you visualize half-hourly smart meter data like this, inefficiencies literally have nowhere to hide.
Of course, I know what you might be thinking. If you're managing a massive portfolio of buildings, you can't just sit there and eyeball every single heat map. For a huge portfolio, we use advanced data science, things like k-means clustering, simply to group similar daily curves together. We also use z-normalization to isolate the pure shape of the curve, totally regardless of the building size. Doing this instantly highlights which facilities have abnormal out-of-hours shapes, and you don't even have to get bogged down in the complex math.
Which brings us to part 3. Spotting the waste.
When you really look closely at those daily curves, specific operational signatures start to jump right out at you. Here are the most common culprits. First, you've got poor automatic HVAC controls that end up conditioning the air for an entire building when maybe just a few rooms are occupied. Second is the classic single timer issue. A building might use a heating timer that only allows one single on-time and off-time for the whole week. And the result of that? The system needlessly fires up on Saturday and Sunday when the building is basically a ghost town. Third, we so often see entire HVAC systems automatically waking up on unoccupied public holidays. And finally, just banks of lights left on well outside core operating hours.
So why does all this matter, and what should you really take away from this? It comes down to the sheer financial impact. Finding and fixing these specific operational settings isn't just some minor optimization tweak. Research shows that by extracting and optimizing these hidden HVAC operational signatures, facility managers can achieve roughly 30% savings in electric power. 30%! We're talking about massive, immediate, and highly lucrative power savings simply by making sure the machines actually turn off when the humans leave.
All right, let's get into part 4, crunching the numbers.
So, the golden formula you need to know is right here. Load factor. Your load factor is calculated by taking your average energy demand over a billing period and dividing it by your peak demand for that exact same period. This is the absolute ultimate KPI, your key performance indicator to track your operational efficiency.
Here's how you actually interpret that math. A high load factor generally means your average demand is creeping up way too close to your peak demand. Think about an office building that's only used maybe 40 to 50 hours a week. In that scenario, a high load factor is a massive red flag. It strongly indicates that your building is totally failing to power down at night. The gap between your occupied peaks and your out-of-hours baseload is just too narrow, which means equipment is almost certainly running unnecessarily in the dark.
To really drive this point home, consider this incredible insight from John Avena at Abraxas Energy Consulting. He says, performing these analyses will likely save you enough money to pay for your utility bill tracking system in the first year. Becoming an energy detective isn't just about environmental sustainability, though of course that is vital. It's about an immediate, undeniably positive financial ROI. The money is literally just sitting there, waiting for you to stop wasting it.
Let's make it actionable. Part 5, our 5-point action checklist. Here is exactly what you need to do right away. Step 1, ditch the monthly bills and go pull your half-hourly interval smart meter data. Step 2, chart it out and explicitly identify what your nighttime baseload is. Step 3, physically audit your building automation system. Go check what those automatic controls are actually doing on weekends and public holidays. Step 4, calculate your load factor for the past month. And crucially, Step 5, adjust your unoccupied set points, widening your out-of-hours temperature thresholds, like, for example, letting the building drift up to 78 degrees Fahrenheit on summer nights before the cooling kicks in will absolutely slash your off-hour waste.
And finally, Part 6, conclusion and next steps. So, we've seen how tracking temporal load profiles, isolating your baseload, and calculating your load factor can catch those hidden thieves draining your budget. But you know, knowledge is only power if you actually use it. So I want to leave you with this provocative thought. What will your interval data reveal about your building tonight? Are you going to let the invisible waste just continue, or are you going to pull your data right now and solve the case? Thank you so much for joining me on this explainer. Keep questioning the data, keep optimizing, and I will see you next time.